So in this video, we're going to practice drawing reciprocal functions. We're going to do this in the same way that we have with our other functions in this series. We're going to draw up a table of values, and then we are going to fill it in, plot our points, and draw our curve. Now, from the last video, you should be pretty familiar with how a reciprocal function looks, and we will just get straight into it now. So substituting all these values in, we're putting the x values into here, and we're trying to populate these ones down here. But now we should be pretty comfortable with filling out table of values. So I'm going to go through this a bit quicker and just try to follow along. Pause the video if you want to have a go on your own, and then you can check to see if you got the correct values. So substituting in -4 gives us -1/2. This one gives us -1. This one gives us -2. We get -4, +4. 2, 1.5. Okay, now you can see in the table of values, I haven't bothered putting in 0 because as we remember, it's undefined, the function's undefined for 0. So there's no point in substituting it in here. Now, once I get these, I'm going to plot this. Now, when x is -1/2, y is -4. So -1/2, -4. When x is I've got this the other way around. When x is -4, y is -1/2. When x is -2, y is -1. When x is -1, y is -2. And when x is -1/2, y is -4. Okay, so I'm going to join this up. Drawing one continuous curve passing through these points. It is a bit hard to draw. And we're going to put our arrows just to show that it continues infinitely. And we're going to do the other side now. So when x is 1/2, y is 4. So x is 1/2, y is 4. X is 1, y is 2. When x is 2, y is 1. And when x is 4, y is 1/2. So now we can join up these. And we get this one. And we are going to continue to extend the graph here. Now, you may have noticed I've been a little bit careless. So I've drawn this so it looks like it's kind of going up a little bit. As you're drawing it, just make sure that your graph looks like it is approaching it, not curving in too much and not really curving out too much, because these graphs are approaching the two asymptotes. So this is my graph of y equals 2/x. And I'm just going to label my asymptotes in as well, because those are important. So I have an asymptote at x equals 0. And I have an asymptote at y equals 0. Sometimes these are shown with dotted lines, but just make some reference that these are your asymptotes. So you can see the graph approaches them, but never quite touches them in both quadrants. Approaches this one, approaches this one. So in the next video, we're going to, next example, we're going to look at another one, but here you can notice that I have this negative in here. So we already know I'm going to expect it in the other quadrants now, but I'm adding a 1 at the very end here. So what I'm going to do, I'm going to substitute all of these values in, and I'm just going to fill out my table of values. So putting in the first one, when x is -4, I get -1/-4 plus 1, which gives you 5/4, or let's write it as 1.25. When we have x being -2, I get basically +1/2 because the two negatives cancel out, and I add 1, which gives us 3/2, or 1.5. When x is -1, I get -1/-1, so that gives us just +1, plus 1 gives us 2. And when x is -1/2, I get 2 in this one. 1/2 gives us 2. plus 1 gives us 3. And other way around, I just put a negative in front. So 1 over a half gives us negative 2, plus 1 gives us minus 1. Minus 1 over 1 gives us negative 1 plus 1, 0. This one, I get negative 1 over 2 plus 1 gives us, should give us a half. And then negative 1 over 4, we have negative a quarter plus 1 gives us 3/4. So 0.75. Okay, so I'm going to write in these values, and you can kind of see, compared to the previous example, these aren't looking as kind of nice as these ones were. So we anticipate this extra thing here had something to do with it. So let's just try to fill it in and just get a general idea of the shape. Now, when x is negative 4, y is 1.25. It's about here. When x is negative 2, y is 1.5. When x is negative 1, y is 2. When x is negative a half, y is 3. Negative a half. Okay. Now, when we get to our value of x is a half, we see that y is negative 1 over here. When we get x is 1, y is 0. When we get x is 2, y is 0.5. And when we get y is 4, this is 0.75. So I can kind of get a rough idea of what's happening, right? It seems like as these ones are getting closer, as we go sort of more and more up here, that already these two numbers are really, really close together. And it looks like the gap between them is smaller than these two is smaller than these two. So we can tell that our asymptote is going to be around here. And these just seem to continue down in this direction. Same with these. It looks like it gets really, really close to this line and it starts to kind of curve up. So this thing is definitely playing a part, and we'll talk about what it's actually doing in a moment. But if I graph this up, I'm going to start. Let's try again. I'm going to get something that looks like this. And I'm going to get something that looks like this. Let's try that again. So I noticed something happening. It appears that my asymptote has gotten shifted up one. So my asymptote, my horizontal one, is now the line y equals 1. And my asymptote here is still x equals to 0. So it appears that this guy seems to be shifting my graph up or down. Now, if you recall our quadratics, we had the same thing happening. Anytime there was something added on the top, it shifted my graph up. Now, if we go back to Desmos here, let's actually just go back to, let's make this just a regular y equals 1 over x. Now, what I'm going to do is I'm going to add another constant c at the end, just to explore this a little bit more. I'm going to add my slider. Now, when this is 0, I still get y equals to 1 over x. What we have done is we have shifted this up one by changing the value of c. So now you can see that we get closer and closer and closer to 1 instead of 0. So my asymptote is at this line. If I just make it really obviously clear, we have y equals 1 as our line. We get really, really close to this line, but even when we zoom in, we can see we're not touching it. So I get this type of thing happening here. If I shift this down, my asymptote just moves. So here my asymptote is at -5. Here it's at -2. So I'm shifting my graph up and down with this extra thing that's getting added at the very end. So this guy over here is contributing to my graph getting shifted up. And I can clearly see it maintains its same shape. However, the asymptote changes. It goes from y equals 0 in the previous example up to y equals 1. But this one stays the same. But that brings us to the end of the video. This is how we can sketch our hyperbolas with a simpler example in the first page and a bit of a trickier one on this page. But we will continue to look at our reciprocal models in the next video. But thank you so much for joining me today, and I'll see you next time.